Question 2. The Texas Star is a Ferris wheel at State Fair in Dallas. The Ferris wheel has a diameter of 61.8 meters. To begin the ride, a passenger gets into a chair at the lowest point on the wheel, which is 2.7 meters above the ground, as shown in the following diagram. A ride consists of multiple revolutions, and the Ferris wheel makes 1.5 revolutions per minute. From this information, we can figure out the period. The height of a chair above the ground, h measured in meters, during a ride on Ferris wheel can be modeled by the function h of t equals negative a cosine bt plus d, where t is the time in seconds since a passenger begins their ride. From this cosine function, we know this a is amplitude. This d is midline. And this b is dealing with period. We can figure out period first. Since t is the time in seconds, 1.5 revolution per minute means 60 seconds. We need to figure out one revolution, how many seconds it will take. That is the period. Let's do the ratio. 1.5 revolution will take 60 seconds. What about one revolution? How many seconds will take? Cross multiply. P equals 60 over 1.5 equals 40. So period is 40 seconds. From this diagram, we can figure out the maximum value equals 61.8 plus 2.7. This is the maximum height equals 64.5. Minimum value is here, 2.7 meters. Amplitude is half the distance between maximum and minimum points. So A equals 64.5 minus 2.7 over 2 equals 30.9 meters. E equals 360 over 40 equals 9. D is the midpoint between maximum and minimum value. So 64.5 plus 2.7 over 2 equals 33.6. Let's go to D. A ride on the Ferris wheel lasts for 12 minutes in total. Calculate the number of revolutions on the Ferris wheel per ride. Use this information. Per minute, 1.5 revolutions. 12 minutes will be 1.5 times 12 equals 18 revolutions. E. For exactly one ride on the Ferris wheel, suggest an appropriate domain for h of t. Since one ride will take 12 minutes, 12 minutes will be 720 seconds. The unit is in seconds. So we will use seconds for the domain of this function. When t greater than or equal to 0, less than or equal to 720 seconds. An appropriate range for h of t. From this wheel, we know minimum value is 2.7, maximum value is 64.5. So h of t greater than equal to 2.7, less than or equal to 64.5. Let's go to J. Big Tex is a 16.8 meter tall cowboy statue that stands on the horizontal ground next to the Ferris wheel. By considering the graph of h of t, determine the length of time during one revolution of the Ferris wheel for which the chair is higher than the cowboy statue. Since we already figured out A, B, and D, so we can write down h of t function. So we got h of t equals negative 30.9 cosine 9t plus 33.6. We want to determine the length of time during one revolution. One revolution means one period. This t is greater than equal to 0, less than or equal to 40. Because period is 40. If we want to use a graphing calculator, then we can set up x minimum equals 0, x maximum equals 40, x scale period over 4, h of t greater than 16.8. We will set up negative 30.9 cosine 9t plus 33.6 greater than 16.8. Let's use the graph on scratch pad. Clear the history, control menu, delete all. Yes. Press tab. Then we put in f1 of x equals h of t. We will change the variable t into x. Enter. Go to menu to change the window. 4. Enter. X minimum 0, maximum 40. Scale 40 divided by 4. Y minimum 0. Y maximum. Let's use 70. Scale 10. Then enter. Press tab again. f2 of x equals 16.8. Enter. We need to figure out these two intersections. Menu, analyze graph, intersection. Control menu, go to recent, intersection. By graphing, we got two roots. T1 equals 6.34054. T2 equals 33.6595. From this graph, we could say when T is between these two roots, the height will be greater than 16.8. In other words, the length of the time will be T2 minus T1 equals 27.3 seconds. H. There is a plan to relocate the Ferris wheel onto a taller platform, which will increase the maximum height of the Ferris wheel to 82. It will change the value of one parameter A, B, or D. Identify which parameter will change. From this wheel, we know this is the minimum value. Here is the maximum value. This will be the midline, which is D. From midline to the maximum, it will be amplitude A. Basically, A is the radius of this Ferris wheel, which means if you only increase the height of a platform, radius of a Ferris wheel won't change. Means A won't change. B is related to the period. Period is nothing to do with the height of this platform. D is the midline. If we increase the platform, this midline will increase too. So D is the only parameter will change. Find the new value of the parameter identified in part H. Since maximum is 82, diameter equals 61.8. So 82 minus 61.8 will be the height of the platform, or it's the minimum value of this Ferris wheel, equals 20.2. So D equals 82 plus 20.2 over 2 equals 51.1.